All right, continuing on our quadratic transformations, today we're going to talk about reflecting over the x-axis and vertical compressions and stretches. Once again, I have my parent function already completed. Looking at our vertex form of the quadratic function, you'll notice that what we're focusing on today is out in front of the parentheses. It's that a term. We've already learned in previous discussions that if our a is positive, our parabola is going to open up. If our a is negative, our parabola is going to open down. But truly what's happening there is if our a is negative, then it's being reflected over the x-axis. Now, the actual value of a is going to cause either a vertical compression or a vertical stretch. And we're going to look at what type of value will cause which type of transformation. So with our parent function, the first transformation that we are going to apply is the opposite of our parent function, negative f of x. Again, our parent function table is completed. So then now for our transformation, we're looking at the same x values. However, this time we want the opposite of the parent function's y values. So when x is negative 2, y is negative 4. When x is negative 1, y is negative 1, etc. And now we're ready to graph this relationship. I'm going to start by graphing my parent function in black. So here you can see our parent function compared to our transformed function. And ultimately, our graph was reflected over the x-axis. The graph is the same distance away, but in the opposite direction from the x-axis. So I would describe this as saying that the parent function reflected across the x-axis. Let's look at our next transformation. This time we want 2 times the parent function. Our parent function table is already completed, so for our transformation, we're still using the same x values. However, this time we're going to multiply our y values by 2. So when x is negative 2, y is 8. When x is negative 1, y is 2. When x is 0, y is 0, etc. Once again, I'm going to graph both relationships. So here we have the parent function, and then we have our transformed function, 2 times the parent function. And with that, we want to observe what has happened. You'll notice that the transformed function is actually narrower than the parent function. What's causing the graph to become more narrow is it is becoming vertically stretched, like it's being pulled up and then it's becoming more narrow. Well, that means that the parent function is being vertically stretched by a factor. Here's our next transformation. This time we want 1/2 of the parent function. So our scale factor, instead of being a 2, which is greater than 1, this time we're dealing with a fraction, a number less than 1. And we're going to see what effect that has on the parent function. Using the same x values, this time I want 1/2 of each of the y values. So when x is negative 2, y is 2. When x is negative 1, our y is 1/2 or 0.5. When x is 0, y is still 0, etc. Now I'm going to graph both. Labeling my graphs, my parent function is here in black, and my transformed graph is here in red. Once again, analyzing what has happened. This is a result of the graph being compressed. It's like it's being squeezed down, which has caused it to become wider. That means that whenever we have a number less than 1, between 0 and 1, our graph is going to become vertically compressed by the scale factor. So the parent function is vertically compressed by a factor of 2. Just a reminder, whenever we're working with our compressions and our fractions, our scale factor is actually the denominator. Let's make some predictions given a function. I'm going to focus on 5 and 6. So first, looking at number 5, given 1/3 f of x, my equation would be g of x is equal to 1/3 x squared, which means that it would be vertically compressed by a factor of 3. Now looking at number 6, this one, we actually have two things happening. The negative tells us that it's going to be reflected. Our equation is going to be g of x is equal to negative 4x squared, and our verbal description. The parent function is reflected over the x-axis and vertically stretched by a factor of 4. Next, we're going to work from a verbal description. This time, I'm only going to focus on number 7 and number 9. So starting with number 7, reflected over the x-axis, I know that that's going to be the opposite of my parent function, which is going to give me negative x squared. Number 9, vertically compressed by a factor of 5 and reflected over the x-axis. That's going to give me negative 1/5 of the parent function, which is g of x is equal to negative 1/5 x squared.